Hello students, myself Vikas Tiwari. Once again, I welcome you to my channel MAP World of Physics. Also, if you want to download us from Play Store, you can download by the name of Mass Academy Advanced Physics. Okay, so now the season of examination has been started right now. Especially for the board students, just I want to tell you that if you are associated with some brand and still you are not satisfied with your physics performance, then just I am going to start with the series of physics for the class 12th for CBSE board and Rajasthan board. Okay, in that context, today just I am going to start with the very first lecture, very first chapter of the physics, and that is I am starting with electrostatics. Okay, so in the electrostatics, just I am going to start with electric field and charges. Okay, so let us go with the concepts of electric field and charges. So let us start with what is the basic definition of electrostatics. When we are talking of electrostatics, what is the definition of electrostatics? It is the branch of physics that deals with the study of charges which are at rest. Okay, so now here I want to clarify. We will deal here with the charges. Okay, and when the charges are rest and when charges are in the motion, when the charges are rest, we will say that it is electrostatics, and when the charges are in motion, we will say that it will be current electricity, that we are going to deal further in other chapters. Okay, so that is the basic definition of electrostatics. Okay, so what is the basic definition of electrostatics? Electrostatics is the branch of physics that deals with the study of charges which are at rest. Okay, so let us start how the development of this charges and what is the development of electrostatics has been gone. So just in the past 600 BC, around like that, so some observation has been started. When the people started rubbing two things, that then they will come to know that if they will rub two things and some piece of bit of papers and other things will come bring near closer to that particular thing, they will get attracted. Okay, so that is called frictional electricity. So what is the phenomena of frictional electricity? The phenomena of electrifying object by friction is called frictional electricity. So some experiments has been done regarding this particular thing. So what are the experiments? When we will say that any glass rod, I will take a glass rod, okay, and it is rubbed by, this is glass rod, okay, this is glass rod and this is rubbed by silk. Okay, so this is the very first phenomena, when we will rub a glass rod by the silk, and we will again we will take a glass rod, another glass rod, okay, and again we will rub it by silk, and when we will bring them together near, okay, so they will get repelled. So there is a phenomena that is called repulsion between that. Okay, so they will get repel. Okay, similarly, if I will take a ebonite rod, okay, and if I will, this is ebonite rod, and if I will rub it with fur, skin animals, animal skin, that is called fur. Okay, so if I will rub this ebonite rod with fur, and again I will take another ebonite rod, once again I will take one more ebonite rod, and again I will rub it with fur. Okay, so what I will say again, when I will bring them together, okay, so when I bring them near, there is again a process, that is repulsion takes place. But what if I will go with a glass rod, okay, if I am going with glass rod, and when I am going to rub it with silk, while I am taking an ebonite rod, and when I will rub it with fur, and when I bring them together near, okay, so there is a process that is called attraction. Okay, so what these experiments has been suggested. What these experiments has been suggested, that there is some intrinsic property of some material like glass or silk or ebonite rod or fur. There is some intrinsic property that has been modified. Okay, because of that particular thing, this process has been take place. So by the experiments we have found that the glass rod gets some positive charge. Again this glass rod will get some positive charge. Okay, so they have got the charge, they will start repelling. Again the experiment says that this ebonite rod will get negative charge. So again they are repelling. Again, what about this particular thing? This silk rod has positive charge, okay, and this ebonite rod has negative charge, so they have been get attracted. Okay, so how this phenomena has been takes place? Some of the electrons that has been passed from glass rod to the silk, so the silk become negatively charged, this will become negatively charged. Okay, so means that some electrons has been transferred from glass rod to the silk, so that silk becomes negatively charged while this glass rod becomes positively charged, right, like that. Some electrons has been transferred from fur to ebonite rod. Okay, so the electrons are moving, that's why the electrons will get moved and transferred to the ebonite rod, so their nature will become negatively, they are more negatively charged, and this fur will become positively charged. Okay, so this is the basically the thing what I am going to tell you, that transfer of electrons takes place in this frictional electricity. Okay, frictional electricity, two things gets rubbed, and because of that particular thing, that object gets electrified. Okay, so electrified means they will get some sort of charge. Okay, so this glass rod has got positive charge, this ebonite rod has get negative charge. On the other hand, this silk will become negatively charged, and here the fur become positively charged. Okay, so from here we have just identify a intrinsic property of any material, and that is called charge. So how we are going to define this particular thing? Charge is an intrinsic property of matter, okay, which is responsible for the production of electric field. Right now just you have to wait, what do you mean by electric field? Okay, so just I am tell you, electric field is there where because of some charge there is some electric field, and in that electric field, if any other test charge experience force, that is called electric field. Okay, so charge is an intrinsic property of matter which is responsible for the production of electric field. Again, there is one more definition for the charge. Charge is that property of matter due to which it experience electric force in the presence of electric field. Just I will elaborate this point so that these two definitions will become clear to you. So what we are saying, later on we will go elaborate what are electric field and what are forces. What I am saying, suppose there is some charge. Okay, so whenever there is a charge, there is an electric field around it. Okay, so in this electric field, if I bring some another test charge, okay, so that this test charge will experience a force. So there is an electric field in which if any other test charge has been brought, then it will experience a force. So this is the basically a proper definition of charge. Okay, so this is the basic definition of charge, and this is what we are saying, what is frictional electricity. So we have started with the definition of electrostatics, then we have gone with definition of frictional electricity. What is frictional electricity? Again I am saying, by rubbing two objects, those objects get electrified. Okay, and that is particular called frictional electricity. And why they are getting electrified? Because there is an intrinsic property of matter which is called charge. Due to charge they get electrified. So the nature of charge should be of two types. it should be either positive type or it should be either negative type. So based on this particular thing, just let us go with another topic, and that is called what are the properties of charge. What are the properties of charge, that we will list one by one. Okay, so next topic, that is properties of charge. Okay, so let us start with very first point. What are the properties of charge? Charge is a scalar quantity. Charge is a scalar quantity, and since it is a scalar quantity, charge is a scalar quantity, therefore it can be algebraically added or subtracted. Therefore it can be algebraically added or subtracted. Later on we will see how we will go with addition and subtraction of charges. It can be algebraically added or subtracted. So this is the very first properties of charge. Okay, now based on our practicals, okay, based on the practicals, charges are of two types. Charges are of two types. First one is positive charge. First one is positive charge, and another one is negative charge. So charges are of two types. First one is positive charge and another is negative charge. Okay, so let us say what is the example of positive charge. So based on our knowledge, we can say proton is positive charge. And what is negative charge? Electron is example of negative charge. Okay, so this is the second property of charge. Okay, what is the third property? Like charges repel each other, that we have seen. Two glass rods, they are repelled. Two ebonite rods, they are repelled, but a glass rod and ebonite rod, they are get attracted. So like charges repels while unlike charges attracts. Unlike charges attracts. So that ebonite rod and glass rod has been attracted because of unlike charges. Okay, so this is the third property. And next property, what is the next property of charge? Charge is quantized. Charge is quantized and obeys conservation law. Obeys conservation law. Okay, so what do you mean by quantization? This is very, very important to understand. What do you mean by quantization? So here just I am going to explain what is mean by quantization. Here just I am taking just two markers. I have two markers in my hand. Okay, so let us decide what is the price of this one marker. Let us I decide that the price of this particular marker is 10 rupees. Okay, so similar marker, it is also have 10 rupees. Okay, so I have decided the minimum value of this one marker. So if I want to sell a marker, so I will sell it like that. Just I am selling first marker and I will take 10 rupees. Then I will sell second marker and I will take 10 rupees. Okay, similarly if I want to buy, just I will buy a one marker and I will give 10 rupees like that. But it is not at all possible that I have sold a one marker, okay, and just I will break and I will sell another half marker. It is not at all possible due to the quantization nature of this marker. Similarly, like that, the charge has been quantized. What do you mean by the charge has been quantized? The minimum value of charge has been fixed to 1.6 into 10 ki power minus 19 coulomb. This we have already studied in 11th class in the Millikan oil drop experiment. What is the value of charge? the value of charge has been decided to 1.6 into 10 raised to power minus 19 coulomb. So whenever the transfer of charge takes place, it will be the integer multiple of this value. Okay, so like that, if I will say from one body to another body, if the charge is going to take place, so it will be like that. One electronic charge means 1 into 1.6 into 10 ki power minus 19 coulomb, it will get transferred. Or from this body to this body, if the charge will transfer, it will be like this only. Or 2 electronic charge, 2 into 1.6 into 10 ki power minus 19 coulomb from this body to this body, or 3 into 1.6 into 10 ki power minus 19 coulomb. Like that, the charge will transfer, will go from one body to another, or will come from another body to one body. It should be in the integer multiple. It is not at all possible that the value of charge means 2.5 into 1.6 into 10 ki power minus 19 of coulomb of charges that has been transferred from one body to another body, because of this value is not an integer value. So charge will be a quantized. Charge will quantized meaning that charge will be transferred from one body to another body, okay, in the form of, or the charge will have the value of plus minus n into E, where E is the minimum value of this particular charge, that has been 1.6 into 10 raised to power minus 19 coulomb, and n is some integer value. N is some integer value. So this is what we call quantization of charge. Okay, so charge always, it is quantized, and it also obeys conservation of law. Means charge neither be destroyed nor be created. It has some fixed values. Okay, so it has always been conserved. Okay, so this is the fourth property of this particular value of charge. Okay, there is one more particular value of this charge, is that charge is an invariant quantity. Here I am writing charge is an invariant quantity. Invariant quantity. Okay, so what do we mean by this invariant quantity? When we are talking, means it does not varies with velocity. Means it is not going to change with velocity. Okay, so we are saying q rest is equal to q motion. If charge is in the get started in motion, the value of charge will not get be changed. Why I have written this? Because the significance of charge is valid for Einstein theory. Einstein theory is that where relativity has been introduced. What do you mean by relativity? In the Newton's physics, Newton's has been explained three basic quantities: mass, length and time, MLT. These are constant. If a body is moving, if a body is in motion, then these mass, length and time, these becomes constant. Okay, so what do you mean by mass, length and time? If a body is moving with some velocity, its mass is not going to change, even the length of the body is not going to change, and in the time frame in which the body has been the motion has been measured, that is also not been changed. Means if there are two observers, if there is an observer, he has already wearing a watch, and if somebody who is in motion, that is also wearing a watch, due to the motion of this particular watch, the time of this particular watch which is in motion has not been changed. Okay, that is in the non-relativity, that is called non-relativity. Mass, length and time, these are remains constant. But in Einstein physics, when we are talking about Einstein physics, that is called theory of relativity, these three quantities are variable. How these are variables? According to Einstein, the mass of moving body is equal to m naught upon under root 1 minus v square upon c square, where m naught is called rest mass. Okay, if a body is at rest, then it is at, this is called m naught is the rest mass, and mass is varying as the body is moving. Mass is varying, mass is changing as the body is moving. So this is what we called the mass is variable quantity in Einstein theory. Also, length is equal to L is equal to L naught under root 1 minus v square upon c square. Okay, this phenomena is called length contraction. It means if a body is moving, according to Einstein, if a body is moving, its length gets contracted. This phenomena is called length contraction. Like that also, T is equal to T naught under root 1 minus v square upon c square. This phenomena is called time dilation. Means if a watch which is moving, its time gets slow. Okay, means its measuring time frame gets slow. That is called time dilation. So time dilation, this is according to the Einstein. So how we can differentiate when we have to use Newton's physics and when we have to use Einstein's physics? Okay, so it is all about the motion velocity of particle with comparison to velocity of light. Okay, so if v is velocity of particle, v is very less than velocity of light, then we follow Newton's physics, in which mass, length and time is constant quantities. Okay, by the motion, due to motion, these three quantities won't get changed. But if velocity of particle approaches nearly equal to velocity of light, means it will get the order of velocity of light, then mass, length, time are no more constant quantities. These are variable quantities. So this is what we call, if velocity of particle approaches velocity of light, then this is basically called theory of relativity. Okay, so these are the particular some properties of the charge. Again, just I am repeating, charge is a scalar quantity. It can algebraically added or subtracted. Okay, means if I have plus 3 coulomb of charge, then or I have minus 2, if I am going to add, I can add plus 3 coulomb plus minus twice of coulomb, so it will become 3 minus 2 is equal to 1 coulomb of charges. Okay, so this is what we call, since it is scalar quantity, then that's why I have used the word algebraically. If it is a vector quantity, if I will use its vector sum or vector subtraction. Okay, according to the nature of quantity, we can use the word algebraical or we can use the vector. Okay, so vector addition is somewhat different from algebraical addition or subtraction. Okay, so second property, it is of two types, positive and negative charge. Third one, like charges repel while unlike charges attract each other. And the fourth one is the charge is quantized. I have already told you what is the meaning of quantization of charge. Charge can be transferred from one body to another body in its integer form. Okay, integer form means the minimum value of charges has been already fixed, and according to that minimum value, the charge will be transferred from one body to another body. And it also obeys conservation law. Charge is conserved. Okay, and finally this one, charge is an invariant quantity. It does not varies with velocity. Q rest is equal to Q motion. Means if a body is moving in this frame where velocity of particle is very less than velocity of light, the charge will also Q. While if a body is moving in the frame of reference where velocity of light is velocity of particle approaches where, then also its value is q. So since MLT are changing but charge q will not change in both the frame of reference. Okay, so these are the particular. So in the next lecture, just we will discuss about the other prospects of electrostatics, electric force, what is electric force and what are electric fields. Thank you very much.